Now we know that the planet Mars, now a dry, dusty desert world, once had rivers, lakes, maybe even oceans. Would you ever have believed that? Where did Mars conceal all the water? The story of our neighboring planet is told on this fascinating journey. We'll also learn what this discovery means for the future, as we explore evidence of water on Mars, from the earliest observations with telescopes to the latest findings from Mars missions. Using available data, we trace humans' view of Mars. Today, a dry reddish landscape decorated with desert-like terrains, mountains and deep canyons. That first impression is a little deceptive, though. Mars has secrets that tell us there was a far wetter past. But the discovery of water on Mars starts back in the 19th century, when Italian astronomer Giovanni Schiaparelli discovered with his telescope strange linear structures on the surface of the red planet. The first meaning of canali was channels, nothing else. The Italian astronomer related the quine to a known waterways, and there was already in circulation too a false report which had survived many years. There were stories all over the world of artificial waterways and a Martian civilization so advanced it should have naturally led to discussions about the possibilities of humanity elsewhere in the universe. This enthusiasm then gave way to a kind of panic, since the idea of Martians had been born, and they were not always depicted as friendly folk in literature and films. We know now today, however, that these canali, channels, are not extraterrestrial work, but are instead geological features, indicative of the former existence of liquid water on Mars. We're long past the time of the modern space probes and rovers clarifying that there are no Martians on Mars. When the first space probes during the 1960s and onwards made images of a completely dry and barren world, it was shocking. But we humans aren't giving up, and look like we're right with our Mars exploration missions. Huge, dried-out riverbeds, tens or hundreds of kilometers, long have been found by orbiters and landers, with sedimentary features characteristic of ancient lakes and deltas, minerals which can be formed only by water. This is of particular interest here, especially with the discoveries on Mars by the Mars Rover Curiosity, which has found evidence of former rivers and lakes in the Gale crater on Mars. And these are not just simple rivulets, these are complex networks of dried-up river courses and sediment deposits, and all of them suggest that water once flowed abundantly here, maybe for millions of years. As such, this was a source of evidence which prompted the researchers to reconstruct the history of Mars, and what they had discovered was shocking. Computer simulations show a Mars not unlike today's Earth, with a climate that allowed liquid water on the surface. But the questions remain. How came in so much water? And how did Mars go from being a potentially life-friendly world to the modern, arid, inhospitable landscape that we have today? Usable water ice is a feature exposed on a map. It's incredible sounding, but it's true. The water has essentially been right under our noses, and we have not seen it. Data from NASA's Jet Propulsion Laboratory, Mars Reconnaissance Orbiter, and Mars Odyssey orbital probes were analyzed by scientists. These two probes looked through Mars's surface with two heat-sensitive instruments and found something researchers missed the first time. Using the data, researchers have made a new map and found that Mars appears to have large amounts of water ice beneath its surface. For decades, they've been puzzled by whether most of the water that once probably existed on Mars has gone. So did it evaporate at all into the atmosphere, or did it sneak underground in ways we have no clue of? The NASA scientists' map now shows that Mars only looks like a desert planet on the outside. Beneath the surface of the red planet, as well as at both poles, there are probably rich deposits of pure water ice, and researchers can, based on a Martian soil's heat signature, examine the whole Martian soil from here on Earth and tell what they would conclude about the presence of ice. On Mars, temperatures average out at around 20 degrees C during the day and 100 degrees C at night. But not only on Mars is it very cold, even though this is hardly revealing. Temperatures peak only in the very few days of summer between the equator and 40 degrees C and south of 45 degrees, reaching 20 degrees C surface highs. Interestingly, at least from the Earth's perspective, ice conducts heat better than dry ground. Similarly, the heating of the surface of Mars can be used by astrogeologists to locate large ice deposits in the ground. Using the Odyssey's gamma, Ray spectrometer. The researchers identify the area where the ice deposits have been deposited. Gamma radiation is produced when cosmic rays hit the surface of Mars and is measured by wavelength gamma-ray spectrometers. The radiation varies. However, with the chemical elements in the soil, a characteristic gamma radiation from hydrogen, a main component of water and thus of ice, is emitted, and this radiations can be discriminated from the spectrometer, helping identify these regions because concentrations of hydrogen correspond to the presence of ice. These measurements lead to a map that will be able to pin down where and how deep on Mars water ice is located. The water ice, it appears, is only a few centimeters below the surface. This important finding not only tells us what happened to Mars, it's also of paramount importance for future missions, where humans will go to live and explore Mars for the first time. It boils down to a simple matter of plain language. Settlers to Mars would only need to dig with a shovel to find fresh water. The Martian soil isn't particularly solid either, and the water ice is only 2.5 centimeters deep in some places. But the map shows that on the map, Arcadia Planitia, a plain in the mid-latitudes, is the best area for water, and perhaps therefore also for an initial settlement. The volcanism evident here would be of considerable interest to scientific research. Ultimately, we want to understand Mars not only from the perspective of when it was a water planet and change our view to actually following the complete geological development of Mars. So how does the vapor get into the atmosphere? What many people do not know is that water vapor has existed in the Martian atmosphere since the 1970s. The Viking missions of 1976 made this important discovery. Sensitive instruments aboard the two Mars landers analyzed the composition of the Martian atmosphere. The two Viking probes orbiting the planet while still intact were the great surprise to the researchers on Earth. They found traces of water vapor in the thin Martian atmosphere. That proved that the Martian atmosphere is still able to retain water, and thus that there is a small amount of humidity on Mars, and it must come from who knows where. We know today that the vapor almost certainly comes from the ice layers, and that the small amounts of water that volatilize on Mars on a regional basis throughout warm season times, also with high positive temperatures. The finding was so revolutionary, as it told us Mars, today an arid planet and an unfriendly world, is still subject to water cycles. What we are all familiar with was actually already shown by not one, but a completely different phenomenon, to involve the fact that there must be water vapor on Mars. The reason Mars is called the Red Planet is there is no need to ask. The Martian rock gets the red color from oxidized iron, and oxidation of iron only occurs where there is moisture. The Viking probes of the Martian soil even back then provided evidence for the existence of water chemically bound in the soil. It was assumed back in the 1970s that this water was trapped in the minerals in the soil. Space probes that followed Mars Odyssey and the Mars Reconnaissance Orbiter, and the Spirit, Opportunity and Curiosity rovers have since verified that many Martian rocks and soil samples do contain hydrated minerals. These minerals are formed from reaction of water with some rocks and incorporation of the water into the minerals. These combined results strongly imply that Mars has been a much wetter planet in the past, and that during at least periods of time Mars was very wet. Again, these findings raise further questions. Today we know where water is, but how did Mars go from a rich water world to dry wasteland? What happened to Mars? One thing that fascinates me is how scientists, in most cases of the present, have been able to reconstruct it almost exactly, what happened on Mars given the finding and the data. Rock samples, soil measurements, and water courses that are still visible today provide enough evidence to reconstruct the following scenario. Mars has no magnetic field to protect its atmosphere from the never-ending assaults of charged solar particles, and unlike Earth, it has an atmosphere. This solar wind has buffeted the upper layer of the Martian atmosphere for over billions of years, washing away its water vapor and other gases into space. For short, the Mars Atmosphere and Volatile Evolution MAVEN mission has fed the data that revealed how the solar wind has weakened the Martian atmosphere and whisked away the gases. These are still around today. If the atmosphere got lost, the atmospheric pressure at the surface also got reduced, and the surface water started evaporating. However, at the same time, the cooling trend associated with the greenhouse effect diminished, cooling the planet. The loss of liquid water was increased as the liquid water either escaped into space or froze, intensified by this cooling. The mechanical parts of water loss are well understood, but the chemical part, the bonding of water into the minerals of the Martian crust, is a key piece of the puzzle. Caltech and the Jet Propulsion Laboratory research showed that today, 30 to 99% of the original surface water is trapped in the minerals. A chemical reaction has brought the water into the structure of the minerals. It has pretty much been taken out of the Martian water cycle and locked in the crust. Today there are many confirmed reconstructions with documentary proof of how Mars evolved from a once water-rich world into the dry, dusty world we live with today. Probably they took place some 100 million years ago. What's next for Mars? You probably already know that private space travel company SpaceX is planning to send humans to Mars soon. It's supposed to be the first settlers on the planet and find if Mars is colonizable. Mars at present is an overall inhospitable planet for humans. It has no oxygen in the air, the temperatures are very cold. Mars is always a little darker than Earth because there is no atmosphere to diffuse the light. Without water discovery, it was unclear whether humans could exist and even survive on Mars for a few days. Water makes this possible. Water is so much more than just drinking and use. Water provides fuel. Oxygen can be extracted from water too. These resources on Mars will become essential for future human settlement. Subscribe to never miss another incredible video.